Okay, so in this section we're going to talk about cross sections. So we're going to talk about both horizontal and coronal cross sections, both which are fair game for your test. A couple tips on how to orient yourself, and then some key landmarks in here. So if we look here first, I'm going to first run through all of the horizontal cross sections, also known as axial cross sections, and then we'll go over all the coronal cross sections here. So remember, if I'm cutting axially or cutting horizontals, I'm cutting through my head like this. So I'm cutting in this direction. So we're looking from the top down, versus if I'm cutting a coronal section, coronal means crown, so I'm cutting like this. So I'm making cuts this way. So each of these, you're looking from the front towards the back. Okay. So horizontal, again, we're cutting from the front down. So the first thing you need to be able to do when looking at any cross section is identify if you're more anterior or more posterior. So a great way to do this, your practical, usually they will orient you for it, but just in case, you should be able to check. The best way to do it is to look in here. So this here is my lateral ventricle. If I pointed right here and said identify, be specific, you would call it the posterior horn of your lateral ventricle. So my big tip is that the anterior horn of the lateral ventricle does not go out nearly as far as the posterior horn. So you see how lateral the posterior horn moves as compared to the anterior horn? And if we look over here on this section also, the anterior horn is much more medial compared to this posterior horn, which goes way out here. That's just a good way to orient yourself. Okay, so now we're going to move, these are towards the top, these are towards the bottom of the brain. So at the top of the brain, there's not a lot of structures you can see. But one thing I do want to clarify is that there is a lot of white matter in here. So you see all this white matter in here as composed of gray matter. This has specific names depending on if you're looking at a horizontal or a coronal. If you're looking at a horizontal, these are labeled centrum semiovale. So all this is a lot of white matter. These are association fibers that are moving from anterior to posterior. This is all centrum semiovale. Versus if this was tagged on a coronal section, such as over here, these would be called the corona radiata. So to think about this, you have association fibers and projection fibers. Association going back and forth in the brain, projection going from top to bottom. So the ones going from top to bottom are corona radiata, which are viewed more easily on a coronal section here. The ones that are association fibers are moving from back to front, front to back. These are my centrum semiovale. So just don't get those confused. It's a bit of a hard concept. Okay, now if we move on, get rid of this slice. This is where we start seeing a lot of the actual brain. So if I tagged this and said identify, you would call it the MCA or middle cerebral artery. So remember, your MCA lies here within this region being, if we tag this gray matter here, you would call it the insula. This whole opening in this area is called the lateral or sylvian fissure. So lateral sylvian fissure, you open it up to find the MCA and the insula. Again, we said this is anterior, this is posterior. Towards the very anterior portion of the lateral ventricle, you're going to get this structure. This is the head of the caudate nucleus. So the caudate nucleus, the head is always going to be next to the lateral ventricle, and actually you can see some of this gray matter going backwards. This is body of the caudate nucleus, which you don't often see. So head is a large section next to the lateral ventricle, which I'll show you on more slices in a second. But the body moves posteriorly, and then will eventually wrap around to have a tail. The tail is very hard to see. I'll show you on a coronal where you can see it, but the only main tags you're going to see is a head anteriorly or a body if you're very superior. So this is a very superior cut. So if I move over here, then you can see that I have a head, but now there's no gray matter behind it, so the body is gone, so I'm too inferior for the body. And again, the tail is very hard to see. Last thing on this section over here, I'm going to tag a couple more things. So if I tag this, you would call this choroid plexus. So in another video, again, I talked about how choroid plexus I always thought looked like a fungus in the ventricles. That's a great example of it. What if I tagged here and said be specific? So this is the splenium of the corpus callosum. So again, we can orient ourselves, because this is posterior because of a large lateral horn. I am posterior, so the posterior portion of the corpus callosum is the splenium. versus this anterior portion here is the genu. This in the middle actually is my septum pellucidum, or that film, or that film that's between the corpus callosum. Okay. Moving on from this slice now. So this is kind of the meat and potatoes of the axial slices. So again, we talked about how we have a head of a caudate here, but we can also complete most of our basal ganglia in this region. So remember, the basal ganglia has a head of a caudate, and then it has, and it's a little hard to differentiate in here, so I'm going to show you a drawing in a second. But if I showed you to identify this slightly darker strip of gray matter out here, what would you call it? So that is my putamen. So if we look over here, Dr. George always talks about the pizza of the putamen. So we look at our putamen, making a beautiful pizza. The putamen is actually the crust. The globus pallidus is the pizza slice. And if you look carefully, you'll actually see that the globus pallidus externa and interna are divided into two. So remember, putamen, globus pallidus externa, globus pallidus interna. If we go back here, again, not well differentiated, but I can see that this putamen, slightly darker out here, is this darker strip, versus my globus pallidus is this triangular portion in here. If I look very carefully, I can see that this is even lighter in here, so this is globus pallidus interna and externa. Again though, I know this isn't the best brain for it, and it's hard to see on camera, so please try to find one in practical. Just understand the pizza analogy. Okay. Since we said this was the head of the caudate, what is this? So this is the thalamus. So the thalamus, which we didn't see more superiorly, is going to be found always next to my third ventricle. So we see our third ventricle in here. I'll show you that in a second. But next to the third ventricle, posterior to the head of the caudate, is the thalamus. So head of the caudate, thalamus. What if I tagged here and said identify, be specific? That's the anterior limb of the internal capsule. So the internal capsule is separating these two gray matter structures, head of the caudate and the thalamus, from my putamen and globus pallidus. This is all internal capsule, and you should be able to identify the anterior limb versus the genu, or bend, versus posterior limb. As we keep moving forward, I always like to remember that this whole area goes gray, white, gray, white. So my next white structure, if you get in here closely and can see it, so between this gray and this thin strip of gray, I have a white structure here. This is my external capsule. So I went internal capsule, external capsule. This very thin gray structure, I'm trying to get the probe out of the way, thin gray structure right here is the colostrum. And just exterior to that, or just lateral to that, is another very thin white structure. This is the extreme capsule. Finally, if we tagged here, we talked about this previously, you would call that the insula. So again, remember gray, white, gray, white, gray, white, gray. First gray is your head of your caudate and your thalamus. Your first white is your internal capsule. Next gray is putamen and globus pallidus externa and interna. Next white is external capsule. Next gray, colostrum. White after that, extreme capsule. And your last gray is your insula. If you understand that, you know a lot that there is to know on horizontal cross sections. Okay, so now we're going to move this slice away and move a little more inferiorly. If I move more inferiorly, put these two parts of the brain together, we can see some more important structures. So at this point, I want you to notice something. We've lost our anterior horns of our lateral ventricles. All we have back here is this. So this is not actually the posterior horn. This is the inferior or temporal horn. So if you remember the shape of the ventricle, and you look here at this hand, this is looking from a mid-sagittal view, and I have an anterior horn, a posterior horn, and then an inferior horn. This will come into play when we look at coronal sections. But here you need to notice that you only have an inferior horn. Your posterior horn is resting here in space, and your anterior horn is up here. Okay. Identify. So this black substance here is substantia nigra, which translates to black substance. So the substantia nigra has to do with dopamine release. It's involved in your basal ganglia pathways, involved in Parkinson's. You'll learn about it, but it's a very identifiable landmark, so make sure you can spot it. This right here, I'm not going to test you because of the cut, it actually looks like there's two of them, but this is your cerebral aqueduct. There's only one going down the middle. So if we remember, our cerebral aqueduct was going down the middle, separating our tegmentum of our midbrain, which we're seeing here, from our tectum, which is back here. So if I pointed here and I said identify, you would call this the cerebral peduncle. So the cerebral peduncle are these large white matter, again projection fibers, moving down towards the spinal cord here. Okay, so a couple other landmarks that you can see in this region. One, we already identified this, being the MCA, lying within our insula. If we look here on the midline surface, I can see this structure. Good, so that's your anterior cerebral artery, or your ACA. So again, ACA is midline, MCA is lateral. Identify this structure here, or here. So that's my hippocampus. So the hippocampus is always very squiggly. Hippocampus means seahorse, and it actually looks kind of like a seahorse, as you can see. It's more apparent also on coronals, but if you're in the area, so if we remember where our parahippocampal gyrus was, the parahippocampal gyrus is located on the inferior portion of the brain medially, just next to my midbrain. And so we know that the parahippocampal gyrus surrounds the hippocampus. So this is all actually hippocampus in this region. And that's most of the stuff you can identify on horizontal. So again, the key things for horizontal is being able to identify anterior versus posterior, and then really knowing this stuff in here, that gray, white, gray, white, gray, white differentiation. We now move on to coronal sections. So remember, coronal sections are looking, here is superior, here is inferior, and we're looking from anterior to posterior. So the first thing you need to do is be able to walk up and tell how far anterior or posterior you are. That can be tricky at first, unless you have key landmarks. So the key thing is to find landmarks such as here. Obviously here, I'm seeing part of my brainstem, so I know that I'm about midway through my brain. Here, I'm seeing the cerebellum. The cerebellum shows up about 2/3 of the way back through the brain. But what if we got to this section over here, and we didn't know how far we were? What if I told you to tag this and be specific? So this is the genu of the corpus callosum. The reason I know this is the genu is because I know I'm anterior. The reason I know I'm anterior is because of the way my lateral ventricles look. So if you remember when we were talking about a lateral ventricle, there's only one anterior horn, but when you get towards the back, there's both a posterior and a temporal horn. So if we look here pretty posteriorly, now I can see both a posterior and a temporal horn. Posterior and temporal horn. So if you see more of an X-like structure of your lateral ventricles, you know you're posteriorly. Versus if you see a V-like structure of your lateral ventricles, you know you're anterior. It's a little tricky to grasp, but if you practice that, you'll feel pretty good. Identify. Good. So this whole region here is actually the head of the caudate nucleus. So remember, the head of the caudate nucleus, as we saw on a coronal section up here, is located near the anterior horn of my lateral ventricle. As compared to this one, where we saw the head of the caudate nucleus here, if you move more posteriorly, this is the body of the caudate nucleus as it moves posteriorly. So if we're very anterior, just next to the anterior horns, we know it's the head of the caudate nucleus. But as we move more posteriorly, it becomes a little smaller, and at this point it's called the body of the caudate nucleus. If we look at this slice too, we also get a really great breakdown of the rest of our basal ganglia and our thalamus too. So here's our body of our caudate nucleus. Identify the area that my probe is lying in. Good, so this is the third ventricle. So the third ventricle is surrounded by my thalamus. So remember, thalamus surrounds the third ventricle, caudate nucleus surrounds the lateral ventricles. So this is a great example of what the third ventricle looks like in real life, because it's difficult to see on a mid-sagittal. And you can see as it would continue down through my cerebral aqueduct. Again, we saw this from a coronal section or from a horizontal section, but please be able to identify substantia nigra. It's really an important tag. If we look now at the rest of our basal ganglia, we saw this. Identify what my probe is lying on. Good, so that's the internal capsule. So in the same way as we saw in our horizontal section, we can also see in coronals that same gray-white, 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 gray differentiation. So remember here, we said this was the thalamus, and this is the body, not the head of the caudate nucleus, because we're more posterior. Then, our first white tract is this large structure, the internal capsule. This is a great example of how you can see internal capsule as a projection fiber, as it's moving through my corona radiata, through my internal capsule, and then through my cerebral pedunculus to get to the spinal cord. Next, we see this large gray differentiation. And again, it's not the best in this brain, but you can differentiate a darker portion here, which is the crust, or the putamen, and then a lighter portion here, globus pallidus. Again, if you were lucky, you could see closely a globus pallidus externa versus interna, but that's very difficult to see. If we go now, lateral to that, again, we have the same pattern of white, gray, white. So this first strip of white matter here is the external capsule, making this gray strip the colostrum, and then this white strip lateral to that, the extreme capsule. Finally, if it was tagged here, you would call that the insula. And then you have a sylvian fissure with your MCA in it. So again, orient yourself in the same way that you do with the horizontals. Understand that gray, white, gray, white, gray, white pattern. Identify. Good, so this is a great example of the hippocampus and kind of how it sort of looks like a squiggly seahorse. So here's his head, here's his belly, he's pregnant because he's a guy, and then his tail's moving over here. This specifically, if I asked you to identify right here, you would call this your uncus. So the uncus, when part of the parahippocampal gyrus is projecting medially and could compress the midbrain, that's the uncus. So you can see how a herniation of here would quickly compress the brainstem and can cause serious damage. Okay. Last thing, we're going to move just a little more posteriorly to these slices here. So as always, if you see your cerebellum, remember you're very posterior. They could always tag something here, and you have to call it a folia. A few other things we can notice here. Remember we talked about how there's two horns posteriorly, so we have both a posterior horn and an inferior or temporal horn of the lateral ventricle. A few other things you can see in this region. If we were to tag white matter back here, and this is a tricky tag, and I'll explain it in a second, but if they tag white matter back here, or actually here's even a better example. If they tag this white matter, what would you call that? So at this point, our basal ganglia is pretty much gone. We don't see our body of our caudate nucleus anymore. If we would see our tail of our caudate nucleus, it would be down here. That might be it, but that's an incredibly hard tag. But white matter in this area is actually association fibers moving towards the back of my brain to bring information to my visual cortex. So these are actually your optic radiations. Let's look over here to see a much better example of optic radiations. So optic radiations, again, carries information from your visual cortex, from your thalamus to your visual cortex. So here's my thalamus here. Here's my thalamus. And this white matter track that travels from my thalamus back to my visual cortex, these are my optic radiations. You have to be able to identify those. That's one of the few association fibers that are really identifiable on a gross brain. And that's really all we have for these cross sections. Again, just be able to identify. I did not expect that. Why was I staring at it? Be able to identify. Know that. Damn it. No, that's not true. Why do I feel like I'm missing stuff? There's just not much else here, Chuck.